Good morning, this is Dr. Turner for Integrated Math 1. Today we're going to be looking at 9.1, which is looking at interior and exterior angle theorems. Our primary focus is going to be looking at triangles. However, with the interior angle theorem, we can apply that to any type of polygon. So it's not going to be just triangles. But let's go ahead and jump right into it. So the first thing we want to cover today is what's known as the interior angle theorem. Now, you've seen part of this before, presumably. A lot of students would at this point be able to tell me that the angles of a triangle add up to 180 degrees. And that in a rectangle or a square, angles of that shape or any quadrilateral would add up to 360 degrees. But then we get into other types of shapes, let's say a pentagon or a hexagon. And the question is, well, if I'm looking at a shape, and it doesn't have to be a normal polygon, but for any polygon, we want to be able to determine what the angles of that shape are going to add up to. So your angle sum theorem for polygons is given as n minus 2 times 180 degrees, where n is the number of sides of the shape that you're looking at. So for any polygon, and we're talking about a convex polygon, basically all the corners are sticking out, and it's a polygon, so we have all flat sides, we don't have any curved sides. For any of those polygons, we take the number of sides, minus 2, and multiply it by 180. So just like in a triangle, there are 3 sides, 3 minus 2 is 1, times 180 is 180. In a quadrilateral, 4 minus 2 is 2, times 180 is 360. And so for a pentagon, we would have 540 degrees. For a hexagon, we would have 720 degrees, etc., etc., etc. So if there is a question like this on the standardized test, you're going to be given the number of sides of the polygon and asked to determine, okay, based on the number of sides, what do the angles add up to? Okay. Also, and this is less common, but if I told you the total number of degrees, you could be asked to determine how many sides that shape is. So for instance, let's say I gave you a shape where we have 1,080 degrees as the angle sum. I could ask you for a normal polygon, or for any polygon, how many sides does that shape have? And so you'd be kind of working backwards here. We know that the total angle sum is determined by the formula n minus 2 times 180. So on the other examples, I gave you the number of sides and asked you for the angle sum. If I give you the angle sum and ask for the number of sides, then it takes a little bit of arithmetic. So here, just like any other algebra problem, I would divide by 180 on both sides, and then get n by itself, add 2 on both sides. So a polygon whose angle sum is 1,080 degrees is an 8-sided figure, or an octagon. Okay, so that is your angle sum. That is for interior angles. And then we have the exterior angle theorem. Now, exterior angle theorem is focusing primarily on triangles. You can have an angle sum theorem for shapes other than triangles, but for us, we're focusing on triangles here. So what an exterior angle is, as the name might imply, is that it's an angle that is outside the triangle. So it's not interior, it's not inside, it is outside. In a triangle, we have 3 angles, and we just got done saying that the interior angles of a triangle have to add up to 180 degrees. If I draw a line through one of the sides of the triangle, and here I'm drawing it along the bottom, but it would be true for any side that I extend, the angle that is formed outside of the triangle, that is an exterior angle. Your exterior angle theorem is that the exterior angle formed in such a way is equal to the sum of what are known as the remote interior angles. So 1, 2, and 3 in this diagram are all interior angles, but the remote interior angles are the ones that are not touching the angle that we're looking at. So for angle 4, the remote interior angles would be 1 and 2. Now, if we were in person and we were doing 2-column proofs, you would be asked to be able to take this and prove, well, why is this true? And without going through the entire proof in detail, we know that angles 1, 2, and 3 have to add up to 180 degrees because they are the angles of a triangle. And we know that angles 3 and 4 have to add up to 180 degrees because they form a straight line. So if I look at this, the only way this makes sense is if 1 and 2 are equal to angle 4. And you can get that by doing substitution. You can get there a couple other ways, but that's essentially how we prove the exterior angle theorem. So for a diagram like this, if I give you the measure of, let's say, angles 1 and 2, and again, not drawn to scale, but let's say 1 is 65 degrees, angle 2 is 60 degrees, and I could ask you, well, what's angle 4? Now, because 9.1 is focusing on exterior angle theorem, you're expected to know that theorem. However, if you forgot that, then you could still get there by knowing that the angles of a triangle add up to 180, and by knowing that the angles that form a straight line add up to 180. So the more direct way would be to take this diagram and say, okay, if this is 65 degrees and this is 60 degrees, well, then exterior angle theorem, add them, you would get 125. If you forgot your exterior angle theorem, then you could still add those together, determine angle 3 by subtracting from 180, which would be 55 degrees. And then, because 3 and 4 make a linear pair, 180 minus 55 would be 125 degrees. So there are a couple ways to get there. The other thing you might be asked to do in this assignment is basically do the same thing, but instead of having integers, you might be asked to solve a problem involving variables or algebra expressions. So for instance, let's say if I said that the measure of angle 1 is 10x, the measure of angle 2 is 3x plus 30, and the measure of angle 4 is 120 degrees. Determine what the value of x is. Now, if I asked you to do that, then you would be going through and saying, okay, well, algebraically, measure of angle 1 plus the measure of angle 2 equals 120 degrees. Okay. And then it's essentially a two-step problem. So combine like terms. You would subtract 90 on both sides, or sorry, 30 on both sides to get 90, and then divide by 13. Now here, because I'm just pulling numbers at random, you end up with a decimal, 90 divided by 13. That is roughly 7.4 approximately. But for the most part for your assignment, I'm giving you values where you end up with an integer as an answer. As always, just because you get a decimal or a fraction doesn't mean your answer is wrong. That's entirely possible. But for your 9.1 assignment, I'm going to try to give you answers where you end up with an integer. That's it for 9.1. If you have any questions, please reach out to me during office hours. Otherwise, have a good day, guys, and I will talk to you soon. Bye.